Hello, my name is Kunal Khallar, and this is my inventory intelligence engine. It answers two questions every warehouse operator actually has. First, how much of this product will I sell? And the second one is, how does it behave compared to everything else I stock? So, those are two genuinely different machine learning problems. Forecasting demand is supervised regression. Given history, predict a number. Segmenting SQ is unsupervised clustering. Given no labels at all, find which products behave alike. I built both, plus a rule based layer that turns their output into one real decision: reorder now or don't. The whole thing is deployed as this live dashboard, not just a notebook. There are total 7 files doing all the work. Let me walk through what each one does. The first one is datagenerator.py. This generates 2 years of daily sales for 60 synthetic SKUs across 5 apparel categories. No external dataset needed. Runs fully offline. Each SKU gets its own demand level, trend, weekend seasonality, and random promo spikes. So every SKU genuinely behaves differently, which both models downstream depend on. The next one is features.py. So this turns the raw sales into a training table. Lag features like demand 7 and 14 days ago, rolling averages, calendar features like day of week. It's shared by training and by live app, so both always see identical features. The next one is forecasting.py. So this is ML concept 1, the supervised regression. One gradient boosting model trained across all 60 SKUs jointly, not one tiny model per SKU. So it shares what it learns about seasonality across similar products. It's evaluated with a time based split, training on the past, testing on most recent 60 days, and it forecasts multiple days ahead recursively. Predict day 1, feed that back as an input, predict day 2, and so on. The next one is segmentation.py. So this is the ML concept 2, the unsupervised clustering. K means groups SKU by demand level, volatility, and trend with zero labels given. It just finds structure on its own. I also added classic ABC XYZ analysis here, decades old but purely rule based, specifically to cross check the clustering against something that isn't machine learning at all. Next one is restock.py. Uh, this is layer that turns both models output into an actual decision. Safety stock and reorder point, the same formulas any real warehouse system uses. Deliberately not ML, this is where two predictions become one number. Order this many units or don't. The next one is training pipeline.py. The one script trains both models and save every artifact. The dashboard never trains live. It only loads what's already trained, so it starts instantly. The last one is app.py. And this is the dashboard itself. Streamlit ties all of it into one interactive page. Let's look at it running. Alright, let me show you the live demonstration now. So we write streamlit run app.py. So this will run the live dashboard. It'll take some time. Okay. So here's the live dashboard. Now uh, let me click the drop down and pick any SKU from here. Let's say this one, SQ16, the hoodies. So in the top left is the sales history and the forecast with the dotted lines uh, for the next 30 days. The model behind this hit a mean absolute error of 8.4 units a day on real held out data across all 60 SKUs. The top right is the segment panel. Here, this SKU shows high demand, stable, and ABC class is A and XY class is X. So every SKU also gets a segment. This one's a high demand, stable, with A class and X for low volatility. Across full catalog, that clustering agrees with classical revenue based ABC analysis on nearly 94% of top tier SKUs. Two completely different methods landing on the same answer. The bottom left is the restock panel. Now, the part that actually matters operationally. If I bump the supplier lead time up to say 15, so as you can see, uh, the safety stock and reorder point update live, like it changes in the real time as I change these parameters. So I showed you that I increase the lead time, and it now shows reorder now. Previously it was saying uh, it's okay, don't reorder. So if current stock is below the reorder point, it tells me straight up reorder now and exactly how many units. So 961 units. The last is the segment map. Now, this is where every SKU is shown, plotted by demand and volatility, colored by cluster. The SQ16 is this highlighted star, as you can see. If I remove all these, so SQ16 is this one. All right, so that was the entire project. Two different ML techniques, one rules layer, turning them into a real decision, all running live. The code and full report are linked in the report itself that I uploaded. So, thank you.